Alright, hi everybody, welcome to video number 35. In the last video we downloaded a digital elevation data set of Mount Shasta in Northern California, and our ultimate goal is to make a volume estimate of Mount Shasta. So in this video I want to show you how to convert the floating point data that we downloaded into an integer format. So first I'll talk about what the difference is between these two things, and then I'll show you how to convert the floating point data into an integer. So as we'll see in a minute, the data we just downloaded, each elevation value is recorded as a decimal, so 2500.543 meters, for example. And the problem with this is that the file is actually having to remember all these decimal places and store each decimal place as a bit of data. But in reality, we don't need these decimal places. We really only care about elevation to the nearest meter. It might even be good enough for us to have it to the nearest 10 meter interval. In any event, we certainly don't need the decimal places. So if we can round or chop off this decimal point and only keep the integer part of it, that's going to mean we have to keep track of less bits, and our file is going to end up being much, much smaller, which is going to make it much easier to work with. Okay? So imagine we start out with a floating point of 2500.543. If we convert to integer, what that's going to do is literally chop off everything after the decimal place. So this number would become 2500, an even integer. Now, there are actually ways to store decimal data as an integer. For example, if we just multiplied this floating point by 1,000 before we stored it as an integer, we could actually store that same number as a single integer, and we would just have to remember that the last 3 digits were actually after the decimal place. So that's a little trick that you'll see people use sometimes. But in our example today, we're just going to take the floating point data, chop off everything after the decimal point, and round to the nearest integer. One final consideration: when is it okay to do this? In our case, we're making a rough volume estimate, so the uncertainties in our calculation are going to be way bigger than would be encompassed by these decimal places. But if we were doing a different calculation, it might be critically important to keep those decimal places. For example, if you were computing the temperature of Lake Champlain and your data was in degrees Celsius, there'd be a big difference between 20.1 degrees and 20.9 degrees. And you definitely would not want to store that data as an integer because you'd be losing a lot of information. So you got to be careful about when it's okay to convert to integer, and you don't want to do it all the time. But in this case, we have really big files, so we're going to go ahead and convert them to integer. Okay, so at the end of our last video, you should have downloaded the elevation data set, and you should have that in your tutorial folder here. I've got it under elevation, and that should have come in as a zip file, which you would have unzipped with 7-zip, and you would have expanded it out into all these other files. And notice right off the bat that the main data file, the IMG file, is 242 megabytes. That's really big. And we've got that one, plus we've got this other one, the second one, 151 megabytes. So we've got something like 400 megabytes of data here. That's a lot. It may choke up our computer. So that's why we're going to need to convert to integer. So let's go ahead to ArcMap. I've got both these DEMs loaded, and you should too. You can see the elevations are displayed on a grayscale right now. So this is going to be the top of Mount Shasta. Over here in dark, this is going to be the bottom. And you can see also, of course, that this is in floating point format. We have these decimal places. To check on that in a formal way, you can right-click and go to Properties and look at the data type here. Pixel type is floating point, and it's stored as a 32-bit. So it's not even an 8-bit, it's 32-bit. We're storing way too much information here. So we definitely want to shrink this down. And the way to do that is to use the integer tool. That can be found under Spatial Analyst, Math. There's a whole bunch of choices. One of them is this int, or the integer tool. Now before I use this, I should say you can also execute this tool in raster calculator just by typing int parentheses and then whatever raster you want to convert. But we might as well use this standalone tool for today. So I'll start out with the first image, load it in there, and then I'm going to specify a file name. I'm going to call this ned25_int for integer. Use the .tiff extension. And the reason I chose 25 is to remind myself I'm doing this file 25 now. I'll do 50 next. So I'll hit save and then hit OK. Let it do this calculation. Okay, so that calculation finished and it loaded the integer data set. Notice that there's no longer any decimal points on this. And let's go have a quick look at the actual data set itself under Windows Explorer. Here's the one I just made. It is now 29 megabytes, down from 242 megabytes. So it was shrunk by almost 90%. Totally worth doing. Okay, so what I'd like you to do now is go ahead and convert the second file, this one, the x50, and then delete all the other files, and we'll move on to the next step. You've now learned how to convert floating point data to integer, and in the next video I'll show you how to mosaic these two DEMs and then clip them to the area we want. Thanks for listening.